And as soon as I do that, the system will start collecting data again. And there we go. The system is now going to respond to the new set point command that I have issued to it. Now, when you make changes to your configuration file, like you change the proportional band, or you change the reset time, or the derivative time, or I'm sorry, the proportional band, the integral time, or the reset time, or the rate time, you have to do it using the controller configuration software. And what's important to note about that is that you will change the proportional band setting using output 2, and you'll change the reset time and the rate time on output 1. That's going to be very important that you know that, because if you don't change the proportional band on output 2, the system will not respond to the new proportional band setting. So that's going to be important that you remember that. And once you're done collecting data for a trial, what you have to do is stop data collection. So you press Control E, E for end, and that's it. The data collection stopped. And so to save your file, use the File Save As convention. Give your file a unique name and save it on the desktop. And then once you're done, you want to reopen a new copy of this PCL DAQ600 in order to start your next trial. And so that's it for this part of the experiment. Now we're going to move on and talk about the Gunt apparatus right over here. And I'm not going to spend a lot of time talking about the Gunt apparatus because the operational aspects of it were covered on the video for the process dynamics. Plus I have also sent out the brochures for this experiment that talk about the final control element and other specifications for this particular system, how it's all constructed. But one thing that was we found out early on in the process dynamics part of the experiment is that this system is very sensitive to how you save your data. And it's going to be very important that you understand this. So to save the data, you have to press the Save Graph feature on this software. But what it does is it only will save the data that's displayed on the graph. Now in the beginning, it's very convenient to use a feed time base that's around 120 seconds. So you can see immediately what's going on with the system. But in order to save all the data for the entire trial, you'll want to expand that feed time base so you see all of it. And so you want to set this to a large number, like 5,000. And notice how now there's a big space back here on this side of the data. That means that I've got all of my data. And so when I click Save, it's going to save everything that you see on the screen. It'll prompt me for some information. And this is where it actually saves the data. You want to save it on the desktop, probably in a team folder that you create. And that's it. And this file can be opened directly in Excel. Open it, say yes, and there it is. So, so that's how you can save the data directly into Excel. Now, when you get ready to start another trial, this is very important. Reduce this back to 120 seconds, and then you want to clear the graph, and so that it restarts, and then you can make your changes. Whether it's a set point change here, you're changing the gain, the integral action, or the derivative time. You can change all those from the front panel. And again, when you see the video for process dynamics, you can, it'll talk about that again. And in process dynamics, we were keeping the derivative time 0. But for this experiment, You're going to look at different proportional gain and the integral action time, and then also, so you look at these two together, and then you also look at the gain, the integral, and the derivative time together as PID control. And you'll compare and contrast how the system performs based on those different settings. And so that's all I want to talk about for this experiment. I hope to see you here soon for reconnoitering. Have a good day.